In this video, I'll demonstrate how to integrate our easy-to-use PTi210 motion control module into an EtherNet IP network. I'll demonstrate how to use the PowerTools Studio comms slot onboard EtherNet tab to map PTi210 module parameters, how to create a new EtherNet IP connection for the PTi210 module using Studio 5000 software, how to modify motion parameters from within a PLC routine. So if you're ready, let's get started. The demonstration equipment that I'm using for this video is connected per the diagram above. As with any system that utilizes a communication field bus like EtherNet IP, care should be taken to ensure that you do not overload the network with unnecessarily high communication rates. We recommend that the RPI interval in the PLC be set to no less than 50 milliseconds for best results. But before we look at the PLC, let's learn how to map drive parameters using PowerTools Studio. Okay, I have PowerTools Studio open, and my project that I'm building, I'm using a Digitex M750 with a PTi210 in slot 2, as you can see there. So to configure EtherNet IP for my application, I'm going to use comms slot onboard EtherNet right there. So I'll click on that. Now by default, there is no protocol selected, so I don't see anything about EtherNet IP on this tab. What I do see is a config tab, and the only thing that I could use that for would be to change the IP settings using PowerTools Studio. So let's add EtherNet IP by dropping the list down and choosing EtherNet IP. Now I get an EtherNet IP tab. Now, let's have a look at this particular configuration setup here. Over on the left, I have a list of PTi210 parameters that I can access using EtherNet IP. These parameters are organized by group. So anything to do with a home, for example, would be here in the home group. Anything to do with jog, the jog group, and so on and so forth. So here are my source parameters. Now over here, I have two tabs, master send and master receive. The master send tab would be used to map any parameters that the master or PLC might send to the PTi210. So for example, we might want to include things like modifying an index distance, which we're going to do, or starting and stopping motion. Anything that the PLC would send to the PTi210 would be mapped here. Conversely, on the master receive, anything that the PTi210 would send to the master would be mapped here. So things like drive status, motor position, so on and so forth. So we have master send and master receive. The way this is organized is you are allocated a total of 32 input and 32 output words. Each one of these words is a 32-bit register. So as you can see, under PTi210 parameters, I have long word 0 through long word 23 for a total of 24 long words for PTi210 parameters. Notice also I can access host drive parameters too, if I would like. Now, I'm not going to be doing that in this example, but I do want to explain how that works. Those of you who have used our products, Unidrive M700, well, any of them actually, know that they are configured or commissioned using a series of menus and parameters. Well, here's your drive menus. Menu 6, for example, parameter 10. So I could access host drive parameters over EtherNet IP through the PTi210 if I wanted to. I'm not going to do that in this example, just to keep things simple, but know that you could do that. So let's go look now at the master send parameters, things that the PLC is sending to the PTi210. So by default, I'm allocated 24 PTi210 parameters and 8 drive parameters for a total of 32. Well, I'm not going to be using any drive parameters, so I'm going to make that 0, hit enter. So now I'm left with 24 PTi210 parameters, word 0 through word 23. So let's go map some parameters. So I'll expand the PTi210 parameters. And what I want to do is I want the PLC to update the position and the velocity of index number 0 using EtherNet IP. And I also want the PLC to start index 0. So over here in the motion view, if I expand that, let's go look at my indexes. There's index 0. Now this index, it's a rotary application, so it's a rotary index type. More importantly, here's the position. Now in the setup view over here, I have designated 3 decimal places for resolution. Our products do not support floating point math. What that means is when the PLC goes to update this position, it's going to do so by sending an integer representation of a decimal value. For example, if I want this position to be 120 degrees, the PLC would send the integer value 120,000, 120, and then 3 zeros to compensate for the 3 decimal places. The drive would interpret that as 120.000. Now I don't have any decimals for my velocity. I could add those if I want, but you must keep that in mind on the PLC side. We do not support floating point. So let's go and map those parameters now. So I'll come back here and I will go to the EtherNet tab and I will expand this list. Mapping parameters couldn't be easier. So I'll expand index 0. There's index 0 distance. To map that, I just grab it and drop it right there. That's it. There's velocity. I'll grab it and drop that right there. So that's pretty simple. Now, and I will touch on this again when we get to the PLC side. Regardless of how you are using or how you are setting up the PLC, whether it's using an EDS file and RS networks or manually, as I'm going to do, the PLC is not going to be able to distinguish what this data is. It's just numbers on the PLC side. You're going to need to record this so you know not only the total number, which I'll also touch on in a minute, but what the function of these words or what these registers are for. So those are both 32-bit parameters, so they consume both of these words. Now I also want the PLC to start this index. So let's move down. Here I have a bit variable called initiate. Now watch what happens when I drag that over. See how long word 2 becomes bit encoded? That means that bit 0 of long word 2 is used to initiate index 0. So again, regardless of the data type, each one of these is a 32-bit register. By bit encoding this word, Now I have a way, or a storage space, as it were, for 32 individual bit variables that I could access using this single 32-bit parameter. So that's a more efficient way of utilizing data on a field bus. So that's all I'm going to do in terms of what the PLC is going to send to me. So now let's snap that together and come here, and you see I have 3 32-bit parameters. So I need to adjust this to reflect that. That value right there is probably the most important thing, besides knowing what these are, because you're going to need to know this on the PLC side too. If this number is wrong, either here or on the PLC side, you're going to get the dreaded I/O not working, blinking light on the PLC side, and we don't want that. So the master is going to be sending the PTi210 3 long words, 3 of 32, and there they are. Now let's look at the receive side, like so. So what I want to send to the master is no drive parameters. Get rid of that. I'll expand this. And what I want to send to the master is I want to send motor position. So position group. There it is. Position feedback. So that's a 32-bit parameter. But I also want to send fault status. So let's go here. And I'm simply going to use drive OK. Now that's a bit variable. So like before, when I drag that over here, long word 1 becomes bit encoded. And there's bit 0 indicating drive OK. I'm also going to send drive active. That will indicate that the drive is enabled, like so. So to keep things simple, that's all I'm going to do. So on the master receive tab, I have 2 32-bit parameters. So I'll change that to 2, enter, and there we go. So the PLC is going to be sending 3 registers, and it's going to be receiving 2 from the PTi210. Now let's go look at Studio 5000 to see how we set up a generic EtherNet module to communicate to the PTi210. Okay, I have Studio 5000 software open here, and I've created a new project for my controller. So to form the Ethernet connection to the PTi210 module, I'm going to begin by adding a module. To do that, I'll right-click here and say New Module. Now clearly we're not a native Allen Bradley device. So the module I'm going to add here is just a generic, and I'll just type generic here, a generic Ethernet module right there. That's what you must use when you're adding a PTi210 to the Ethernet IP network. So I'll click Create. And here's the new module properties. The first thing I'm going to do is give it a name. Now this might seem insignificant, but the name I choose here will become the controller tag name that's going to be used to reference the drive. So I'm going to keep this short and just call it Axis 1. Next, I'm going to point it to the IP address for the PTi210, which is 192.168.1.2. Now over here, this is the most important part of all. So in the connection parameters, these need to be absolutely correct. So the input assembly that we use is 100. The output assembly is 101, and this will be configuration 1. Now the size here needs to be, or it needs to reflect what we did in PowerTools Studio. So as you recall, the input to the PLC would be the master receive. So that's only going to be 2 words. We're only sending position and then the bit mapped drive status and drive enable. Now the output assembly, that is going to be the master send in the PowerTools Studio side, and there were 3 data words for that. So that's all we need to do. Let's click OK. And now we get the module properties. And as I mentioned earlier, with our equipment, I could leave this at 10 milliseconds, but for best results, let's bump that up to 50 and say OK. So that's what we need to do to establish the module itself. Now let's transfer it to the controller and make sure that we did that correctly. So I'll come up here, download. And download my project. It's checking for errors. I'll change that back to run. And there we go. That's what we're looking for. Had I made a mistake in configuring this module, that light would have been blinking. So at this point, we're now ready to use the data coming to and going out of the PLC. I've created a very simple project in Studio 5000 that will demonstrate how to use the data coming to and from the PTi210 here in the PLC. But before we look at the routine that I've created, I want to show you the controller tags for a minute. So remember when we developed the module, or we added the generic module and we called it Axis 1, and I said that that name would be important? Well, here's why. Because what that does is that becomes the label for the data tags, the controller tags now for the Axis. So here in the controller tag editor, I have a tag called Axis_1:I. That's input data. Axis_1:O is output data. Remember also, I suggested that it would be a good idea to keep these things straight. And to do that at the PLC side, originally there was nothing here. So what I did was I just went in and Axis 1 input data word 0, I gave it a description of Axis 1 position because that's what it is. And then the other input word, data word 1, that's the one that was bit encoded. So I've just gone in and added descriptions that will appear in the routine so you know what these bits are. And I've done the same thing for the output data too. So here's my output data. So word 0 is index 0 distance, word 1 is index 0 velocity, and data word 2 is bit mapped, but the only thing we're doing is using bit 0 for index initiate. So those are the things that I've done in the controller tag editor. Now let's look at the routine that I did. Very simple. I'm online with the controller right now, which is why you see these contacts being active or not. So I'm just checking to see that the axis is okay. Now I'm going to turn on the safe torque off on the Digitex M750 and watch this contact light up now. So I am in fact getting data. And then I also wanted to check to make sure that the index distance, there's the label, and velocity are both greater than 0. That's kind of a subtle but important point. Once you map a PTi210 parameter like index distance and velocity to Ethernet IP, then you must update that parameter using Ethernet IP. What I mean by that is, had I not used these move instructions, if those weren't there, and I didn't have this check methodology here, and I tried to run the index, it would not run. And if I were to go look, even at PowerTools Pro would show that there is distance and velocity. But until you actually update the tags using the field bus, in this case Ethernet IP, you won't have distance or velocity in my case. I'm going to show you PowerTools Studio here in a minute. So I get this clear to run controller bit that I created. So I'll just come down here. I'm also moving axis 1 input data word 0, which is the motor position right there, into a controller tag called current position. So I'll move the motor now. I'll just toggle this tag and watch the move box at the bottom now. You see it updates. It moved 90 degrees. I'll do it again. There we go. So we are moving. So that bit is working. Before I get off here, I want to show you a very important diagnostic tool that's available in PowerTools. So let me switch to that. When you are online with PowerTools, as I am now, connected right there, notice you get these two tags or tabs here in the COM slot. That's where I'm at. Online status says I'm communicating. The communication link is okay, but more importantly, you can go in and monitor the data coming from the PLC. So let me go and update or edit this. So I'm going to make this 120 degrees now. 120, 1, 2, 3. And I'll make this velocity 100. Well, let me edit that wrong too. There we go. And I'll make this 120 now. Now, let me finalize the edits. Yes, there we go. Now let's go look at PowerTools and make sure that came through. There it is. So that's a very handy diagnostic tool when you're trying to troubleshoot problems with Ethernet IP. PowerTools Studio software makes it very easy to modify PTi210 application parameters using Ethernet IP. When mapping parameters, it is a good idea to keep track of the function of each data word or bit encoded parameter so that you can label them accordingly on the PLC side. Make sure that the connection settings on the PLC side match exactly the number of master send and master receive words you've set up in PowerTools Studio to avoid communication errors between the PLC and the PTi210. Thank you for watching, and more importantly, thank you for choosing Control Techniques.